Hello students, welcome to my channel Semantic PMT. Today's topic is quadratic equations. This time I've given you my contact details as well as email ID in case you just need to contact me. Today's objective. What is a quadratic equation? That is what we are going to learn in the first. Then students ask me where in life will they be using a quadratic equation. So I have tried to explain you giving a simple example, the use of quadratic equation in daily life. Next, we are going to understand the meaning of a root or solution of a quadratic equation. Then we are going to solve quadratic equation by method of factorization, then completing the square method and formula method. Next, we are going to study the nature of the roots of a quadratic equation, and then finally we are going to form a quadratic equation from its roots. Let us start, students. Let us understand what is a quadratic equation. An equation involving one variable and having 2 as a maximum index of the variable is called a quadratic equation. General form of quadratic equation is ax square plus bx plus c equal to 0, where a, b, c are real numbers and a not equal to 0. What do we mean by this? See, if you observe the example that I have given, root 3x square plus 4x minus 5 equal to 0. Here, root 3, 4 and minus 5 are real numbers. And important thing to note is the coefficient of the x square term cannot be equal to 0. Let's have a look at another example. Is x square plus 2 upon x plus 9 equal to 0 a quadratic equation? Answer is no. Let us understand why it is not a quadratic equation. See, first of all, this equation is not completely satisfied. So, step number 1 is to simplify this equation completely. For that, we multiply each term by x. So what do we get? X into x square plus x into 2 upon x plus 9 into x equal to 0 into x. So what happens when you multiply x with x square? It becomes x cube plus in the second term x and x gets cancelled. So what remains is 2 plus 9x equal to 0. So the equation is x cube plus 2 plus 9x equal to 0. So what is the degree of the equation? Degree means the highest index of the variable. Here it is 3. And what is a quadratic equation? The highest index should be 2 for it to be a quadratic equation. Therefore, the given equation is not a quadratic equation. Please have a look at the note. An equation has to be completely simplified. If final degree is 2, then only it is a quadratic equation. Maths is an important subject which we use in everyday life. Yet, at times, students ask me, कि where in life would they use a quadratic equation? So, I have tried to give you an example, a simple example, to make you understand how we can use a quadratic equation in daily life. I buy a land of 10,000 square feet. I only know that the length of this land is more than the breadth by 20 feet. Now what do I do to find the dimensions of this land? Of course, it is understood that the land is rectangular. So, I assume that the breadth of this rectangular piece of land is x. So its length will be x plus 20. Area of rectangle equal to length into breadth, which is equal to x plus 20 into x. So area we substitute as 1000. So we get the equation as x square plus 20x minus 10,000 equal to 0. Now isn't this a quadratic equation? How to solve this? We will be seeing this further. Let us now understand the meaning of a root or solution of a quadratic equation. A root or solution of a quadratic equation satisfies the quadratic equation. Means, let's have a look at an example. Is x equal to minus 1 and x equal to 1 a root of quadratic equation x square minus 2x plus 1 equal to 0? See, what we do is, in the equation, in the left hand side of the equation, in place of x, we substitute minus 1. So we get left hand side equal to minus 1 the whole square minus 2 bracket minus 1 plus 1. Minus 1 the whole square is 1. Minus into minus is plus. So 1 plus 2 plus 1 equal to 4. Now is that equal to right hand side? No. On the right hand side the equation has 0. What we got is 4. So we say x equal to minus 1 is not a root. What do we understand from this? We understand that if after substituting value of x, if left hand side and right hand side are equal, then that value will be the root or solution of quadratic equation. Let's have a look at x equal to 1. In the equation, I substitute x equal to 1 in the left hand side. So after substitution we get 1 square minus 2 into 1 plus 1 equal to 1 minus 2 plus 1 equal to 0, which is equal to right hand side. Therefore, we say x equal to 1 is a root of quadratic equation given. Let us now have a look at solving a quadratic equation by factorization method. 5x square equal to 22x plus 15. We will solve this equation by factorization method. First, collect 22x and 15 to the left hand side of equality. So their signs will change. Equation becomes 5x square minus 22x minus 15 equal to 0. Now the next step will be, we find factors of the product of the x square term and the constant term. In this case, the product is 5 into minus 15, which is minus 75. So we find two factors of minus 75 such that when you add or subtract them, we get the middle term. Here, the middle term is minus 22. Now, please note, the product is negative, then one factor has to be positive and the other has to be negative, because plus into minus is minus. Then the two factors that we find, which one will be positive and which one will be negative? For that, the middle term sign of the given quadratic equation goes to the bigger factor. In this case, the middle term sign is negative. So, minus sign will go to the bigger factor. Let us start finding the factors. Start with 1. 1 into 75 is 75. Now, one factor is positive and the other is negative. Middle term sign is negative, which goes to the bigger factor. So, it will be plus 1 into minus 75. You apply the addition rules, we get 1 minus 75 equal to minus 74. Do we need that as the middle term? No. Therefore, we move on to the next factors. 2 is not possible. 3 into 25 equal to 75. Middle term sign goes to the bigger factor. So we have plus 3 into minus 25 equal to minus 75. And when you apply the addition rules, we get 3 minus 25 equal to minus 22. So what we have done, we can now split the middle term minus 22x into 3x and minus 25x. So it becomes 5x square plus 3x minus 25x minus 15 equal to 0. So we take x common from the first two terms. Inside the bracket, we get 5x plus 3. From the third and fourth term, we take minus 5 as common. So inside the bracket, we get 5x plus 3 equal to 0. Now 5x plus 3 is a common term which is taken outside. So the other factor becomes x minus 5 equal to 0. By applying product rules, we get 5x plus 3 equal to 0 or x minus 5 equal to 0. So we get x equal to minus 3 upon 5 or x equal to 5. So solution is x equal to minus 3 upon 5 or x equal to 5. Let's have a look at a note. If product is negative, then one factor is positive and the other is negative. Middle term sign of the equation is given to bigger factor. What if product is positive? Then both factors are either positive or negative, and the middle term sign is given to both the factors. Let us now have a look at another example where the product will be positive. 6m plus 2 upon m equal to 7. First of all, we simplify the equation completely to change the equation into quadratic equation. For that, we multiply each term by m. Therefore, we get m into 6m plus m into 2 upon m equal to 7m. Now 7m goes to the left hand side. We get 6m square minus 7m plus 2 equal to 0. So we find the product. In this case, it is 6 into 2, which is 12. So we find factors of 12 such that when you apply the addition or subtraction rules, we get the middle term. In this case, it is minus 7. So start with the first factor. 1 into 12 is 12. But now, since the product is positive, both factors will either be positive or negative. But from the earlier slide, we understand that the middle term sign, in this case it is negative, goes to both the factors. So minus 1 minus 12, on applying the subtraction rules, we get minus 13. We need middle term as minus 7. So neglect these factors. Proceed likewise. We arrive at minus 3 into minus 4 equal to 12, and minus 3 minus 4, on applying the subtraction rules, we get minus 7. So the middle term can now be split as minus 3m minus 4m. Therefore the equation becomes 6m square minus 3m minus 4m plus 2 equal to 0. We take 3m common. Inside the bracket we get 2m minus 1 minus 2 bracket 2m minus 1 equal to 0. 2m minus 1 takes common, comes out as common. So the second factor will be 3m minus 2 equal to 0. By applying product rules, we get 2m minus 1 equal to 0 or 3m minus 2 equal to 0. Therefore, m equal to half or m equal to 2 upon 3. Solution is m equal to half or m equal to 2 upon 3. Let us now learn another method for solving a quadratic equation. This method is called completing the square method. Let's have a look at an example. 6m plus 2 upon m equal to 7. Now, what we do is, we first simplify the equation to make it a quadratic equation. Step 2. Now, coefficient of the square term should be 1. If it is not 1, then divide each term by that coefficient. Step 3. Only constant term should be on the right hand side. Mark this as equation A. Next, fourth step. Third term equal to half into coefficient of m the whole square. Now this term has to be added on both sides of equation A. Now let us apply the steps that we studied in the earlier slide. The sum was 6m plus 2 upon m equal to 7. So we first simplify the equation completely. For that, we multiply each term by m. Therefore, m into 6m plus m into 2 upon m equal to 7 into m. Therefore, 6m square plus 2 equal to 7m. Rule 2. Coefficient of square term should be 1. If it is not 1, then divide each term by that coefficient. In this case, coefficient of the square term is 6. Therefore, we divide each term by 6. So 6m square upon 6 plus 2 upon 6 equal to 7m upon 6. The 6 will get cancelled from the square term. Do not cancel out 2 and 6. We will keep that as it is. Rule 3. Only constant term should be on the right hand side. Therefore, m square, what we do is we take 7m upon 6 on the right hand side to the left hand side of equality, while 2 upon 6, which is on the left hand side, to the right hand side of equality. So the equation becomes m square minus 7m upon 6 equal to minus 2 upon 6. Mark this as equation A. Rule 4. We now find the third term. Formula for third term is half into coefficient of m, the whole square. In the equation A, coefficient of m is minus 7 upon 6. Therefore, we get third term equal to half into minus 7 upon 6 the whole square equal to 49 upon 144. Now this term needs to be added on both sides of A. When we do that, we get m square minus 7m upon 6 plus 49 upon 144 equal to 49 upon 144 minus 2 upon 6. Now the left hand side is a perfect square. That is why completing the square method is being used. Now it is a perfect square of m minus 7 upon 12 the whole square. How do we find that? Take the square root of m square, which is m. Take the square root of 49 upon 144, which is 7 upon 12, and put the sign of the middle term. So we write m minus 7 upon 12 the whole square equal to 49 upon 144 minus 2 upon 6. Take the LCM. So we multiply the denominator of the second fraction by 24 and numerator of the second fraction by 24. Therefore, we get m minus 7 upon 12 the whole square equal to 49 upon 144 minus 48 upon 144. Therefore, m minus 7 upon 12 the whole square equal to 1 upon 144. Therefore, m minus 7 upon 12 the whole square equal to 1 upon 12 the whole square. Now taking square root of both the sides, we get m minus 7 upon 12 equal to plus or minus 1 upon 12. Minus 7 upon 12 on the left hand side goes to the right hand side, becomes positive. So we get m equal to 7 upon 12 plus or minus 1 upon 12. So m equal to 7 plus 1 upon 12 or m equal to 7 minus 1 upon 12. So m equal to 8 upon 12 or m equal to 6 upon 12. Therefore m equal to 2 upon 3 or m equal to half. Therefore solution is m equal to 2 upon 3 or m equal to half. We will now have a look at the third method of solving a quadratic equation. Formula method. 6m plus 2 upon m equal to 7. Now, for solving a quadratic equation by formula method, first step is simplify the equation to form a quadratic equation. Then compare this equation with ax square plus bx plus c equal to 0 and get the values of a, b and c. And then by using the formula x equal to minus b plus minus square root of b square minus 4ac upon 2a, we get the value of x, the variable. In the sum which has been given to us, 6m plus 2 upon m equal to 7, we first simplify the equation. So for that, we multiply each term by each term by m. Therefore, m into 6m plus m into 2 upon m equal to 7m. Therefore, 6m square plus 2 equal to 7m. 7m goes to the left hand side. We get 6m square minus 7m plus 2 equal to 0. On comparing with ax square plus bx plus c equal to 0, we get a equal to 6, b equal to minus 7 and c equal to 2. Therefore, m equal to, use the formula, minus b plus minus square root of b square minus 4ac upon 2a, and then substitute the values. So we get m equal to minus bracket minus 7 plus minus square root of minus 7 the whole square minus 4 into 6 into 2 upon 2 into 6. So m equal to, minus into minus is plus, so we get 7 plus minus square root of 49 minus 48 upon 12. Therefore, m equal to 7 plus or minus square root of 1 upon 12. So we get m equal to 7 plus 1 upon 12 or m equal to 7 minus 1 upon 12. Therefore, m equal to 2 upon 3 or m equal to 1 upon 2. Nature of roots of a quadratic equation. If ax square plus bx plus c equal to 0 is a quadratic equation, then discriminant delta equal to b square minus 4ac. Based on the value of discriminant delta, we determine whether the nature of the roots. If delta is equal to 0, then roots are real and equal. If delta is less than 0, then roots are not real. And if delta is greater than 0, then roots are real and unequal. Let us now have a look at examples where we will determine the nature of the roots. The first example, 2x square minus 4x plus 6 equal to 0. Compare with ax square plus bx plus c equal to 0. We get a equal to 2, b equal to minus 4 and c equal to 6. So, delta equal to b square minus 4ac minus 4 the whole square minus 4 into 2 into 6 equal to 16 minus 48, which is equal to minus 32. Therefore, delta is less than 0. So roots are not real. Now, let's have a look at another example, 4x square minus 2x minus 3 equal to 0. Comparing with ax square plus bx plus c equal to 0, we get a equal to 4, b equal to minus 2 and c equal to minus 3. Find the value of delta. B square minus 4ac, which is equal to minus 2 the whole square minus 4 into minus 3, which is equal to 4 plus 48, which is equal to 52. Therefore, delta is greater than 0. So roots are real and unequal. Now, let's have a look at the third equation. X square minus 4x plus 4 equal to 0. On comparing this equation with ax square plus bx plus c equal to 0, we get a equal to 1, b equal to minus 4 and c equal to 4. Again we find the value of delta, which is b square minus 4ac. On substituting the values of a, b and c, we get delta equal to 0. Therefore, roots are real and equal. Now let us form a quadratic equation from its roots. If alpha and beta are the roots of a quadratic equation, ax square plus bx plus c equal to 0, then sum of the roots alpha plus beta equal to minus b upon a, and product of the roots alpha into beta equal to c upon a. If alpha and beta are the roots, then a quadratic equation is x square minus alpha plus beta into x plus alpha beta equal to 0. Let's have a look at an example. If minus 2 and 3 are the roots, then we have to form its quadratic equation. So we find some of the roots first. Alpha plus beta equal to minus 2 plus 3 equal to 1. Alpha into beta equal to minus 2 into 3 equal to minus 6. So quadratic equation in x is x square minus bracket alpha plus beta into x plus alpha beta equal to 0. Alpha plus beta we found it as 1. So we substitute that value and we substitute the value for alpha beta. So the equation becomes x square minus x minus 6 equal to 0. Thank you students for watching my video. If you have liked my channel, then press the thumbs up button, share it with your friends, subscribe to my channel, and yes, do not forget to press the bell icon for notifications.